Hello class and welcome to this video lesson. Today make sure you have your calculator out with you as you're going to want to follow along with our notes. I do not have a calculator on my computer at home here, so I will have to describe a lot of pictures to you, but I won't be able to actually show them on the screen. Okay, so the point of today's lesson is to talk about how to graph a circle in parametric mode, because as you know in function mode it is impossible to draw a circle because it doesn't pass the horizontal line test, so it's not a function. So that's one of the cool things about parametric mode. So I started off with this circle here, and I'm just going to look at this triangle with a reference angle of t there with my different sides. Well, so I know cosine of t equals adjacent over hypotenuse, so in this case it would be x over r. Sine of t is going to equal opposite over hypotenuse, so y over r. Now to write this in a parametric equation, I need to solve for x and y, and so that means all I would do is go multiply by r on both sides to get x alone. So guess what? X equals r times cosine of t. Same thing for the sine. We'll multiply both sides by r, so we get y equals r times sine of t. So that right there is your general equation for graphing a circle in parametric mode. So let me ask my first question. It says, what parametric equations will give you a circle centered at the origin with a radius of 3? Well, so we know the radius of 3, if you go back to the equation here, is just the number in front, because cosine of t and sine of t are just variables, so r is the radius of the circle. So all I'm going to do is I'm going to go x equals and y equals. X equals the radius of 3 times cosine of t. Y is also going to equal 3 times sine of t, because we have to keep that radius at 3. So you can go ahead and graph this in your calculators. To make sure we all get the same picture, I give you a little box over here. First off, make sure you are in degree mode. Okay. And then this is what I set up for your T-min, T-max, and T-step. So take a moment, why don't you pause the video and try to get the graph to show up. So if you graph it, you will actually notice that it doesn't really look like a circle. It actually looks more oval, or mathematical word for that would be ellipse-like. So what I would suggest is using this zoom key. So it's right in the middle on the top of your calculator. Go to zoom, go down to 5, it says z square. What it'll do is it'll make your x and your y scales actually the same size, because your screen's actually a rectangle, not a square. And so it'll make it look a lot more like a circle, but doesn't actually change your graph. So if you go back to the window button, then you'll see these numbers are probably the ones that are changed, and that's okay. So you got a circle with a radius of 3. All right, moving on. All right, so we've talked before about how the t-step is the time, or in other words, it's like how many reference points you have on the picture. So ideally yours in this last example looked just like this one, pretty circular. But actually, if we have less t-steps, what we would be doing is we would be just connecting the dots. So like here's a dot, here's a dot, here's a dot. So how many different points did I actually graph on this? Well, I graphed 6. So if you think about it, one full cycle around the circle would be 360 degrees. And so to get this graph, all I would have to do is change my t-step into, you got it, 60 degrees. Okay. So going back to this equation right here, my t-step would be 60. This is kind of hard to write on here. And you would be able to get this plot instead of an actual circle because it didn't graph enough to connect all the dots. So then if you look at this graph right here, the triangle, well, how many dots are there? There are 3 points is all that they plotted. So we will take 360 divided by 3. So change your t-step into 120, and I bet you would get that same picture. So why don't you pause the video again and see if you can get these other 3 graphs. I'll give you a hint on this one right here. Notice that it actually doesn't start here at 3. And so I suggest that you not only change your t-step, but you also change your t-min. So like I said, pause the video, mess around with it for a little bit, and then you can start it up and I'll show you what the answers were. So the answer for this one was 45 degrees should be your T-min. This one should be 90 degrees. And then this one, your T-step, excuse me. On this last one, your T-step should still be 90 degrees, but your T-min would be 45 degrees because it starts 45 off of the center. So you'll actually have to know, so you'd have to change your T-max as well. Alright, next again, I'd like you to pause the video and just kind of mess around with your calculator. This is something you do not want to skip. This is really cool. And notice, I did in fact mean for it to be 3,600 degrees for the T-max. And I just picked some random numbers. So my T-step here is 125. Then try changing it to 100 or 150, 185. I just want you to see how cool these graphs are. So it's not probably what you're going to expect because it plots really random points. So like I said, take a moment, investigate. Alright, let's go back to the equation at hand, which is circles. And so I have this circle right here. It's still a radius of 3, but I would like to translate the circle so the center is at 5, 2. Well, we learned just yesterday how to move something. And so what we did is we took our x-coordinate and we added something to it, and we took our y-coordinate and we added something to it. So we know the basic equation was 3 times cosine of t and 3 times sine of t. So if I want to move this center, which was at 0, 0, to 5, 2, I need to go over 5 and up 2. And so how did I do that yesterday? I just added 5 to the x-coordinate, and I added 2 to the y-coordinate. So the cool thing is, in parametric form, everything is at face value. You don't have to think about going opposites on the x's. So then if I was to answer these other questions down here, like this center one right here, I would get that my equation would be x equals 3 cosine of t minus 5, and y would equal 3 sine of t plus 2. Okay? And I could do the same for these two as well, but I think it's pretty obvious. Alright, well, what about ellipses? So I've graphed circles. So if you think about this circle, it goes 3 sideways to the x and 3 up for the y. So if you look at this one right here, this goes 3 to the side, but only 1 up. So if I want to change my formulas, x is always going to be cosine of t, and y is always going to be sine of t. So on the x-coordinate, I went 3 over, and on the y-coordinate, I went 1 up. So that's all. So the numbers in front will change it to be an ellipse instead of a circle if they are not the same value. Alright, again, let's pause the video and try this challenge problem. It's just a bunch of circles and ellipses if you think about it. And so, yeah, pause the video, try it. It's kind of fun. Alright, and finally, so we know how to graph circles. How about lines with respect to still being in trigonometry? So if you look at this first blue example here, I'll get my blue ink so I can match it. Looking at this example right here, I know that cosine of 30 degrees equals the adjacent over the hypotenuse, so x over 1. So actually, x just equals cosine of 30. Oh, cool. Okay. Sine of 30 equals the opposite over the hypotenuse, so y over 1. So y just equals sine of 30. Okay. So I could do the same thing for this red one right here. The only difference is I would have cosine of 30 equals x over 2. We already know we multiply both sides by 2 to get x alone. So this one would be 2 times cosine of 30. Y would be 2 times sine of 30. If you tried plotting those in your calculator, what's actually going to happen on your picture is you are just going to get 1 dot each. So there's a dot. That's my blue graph. My red graph would be about there. Well, that's not very exciting. So what if I expanded that into this case scenario here in green, where I have t as my radius? Okay, so all that's going to do is it's going to put a t in front of the cosine and the y. So it's going to be x equals t times cosine of 30 and t times sine of 30. I apologize, my handwriting's terrible on here. If I graph that, it's actually going to make a line. And you know what's really cool about this? This angle right here is going to be 30 degrees. Pretty neat. Okay, so I think in your homework somewhere they wanted you to graph like a 120 degree angle or something like that. All you'd have to do is, you want to graph that line, think about how do I get 120 degrees out of that. Well, all I would change would be these numbers right here. You can still keep that t in front because that would do all the points instead of just the individual ones at a time. All right, last little tidbits, kind of unrelated, or at least it seems unrelated. We're going to do word problems with this, is we're going to talk about bearings. So this is really real world. Now, normally if you think about our equations on the unit circle, we always did everything with respect to the horizontal axis. So we would always go like this direction when we were doing angles. Bearings are actually going to be in a reference from due north. So you're going to go the opposite direction. So you're going to go clockwise coming from north instead of coming from, I guess this would be east right here and going counterclockwise. You want to think of it that way? So I don't know, this looks like about 40 degrees. So this would be 40 degrees east of due north. Okay? So again, the only difference is you are changing that initial ray. So you're starting from way up and you're going clockwise. Okay? So keep that in mind when you're doing your homework. Alright, that is all I have for you today. So why don't you ask the sub to pass out the mastery number 3 and get working on that. You will need a calculator for it. So I will get to work. Have a great day, guys.